For this problem, we're looking to solve the equation 6 cosine of pi x, and we're going to try to find where that equals 1. The only angles that I want as answers are the angles between 0 and 6 radians. So right away, I'm going to look at the graph, and so here we can see our sinusoid. The amplitude is 6, and the pi is going to adjust our period. And so before I start this problem, I'm going to look at this because this is a little bit different than the rest. So right away, I remember that this number being multiplied on the inside is the reciprocal of the dilation factor. So that means that I'm making it 1 over pi times smaller than our normal cycle. Well, our normal period in radians is 2 pi, so I'm going to multiply that by the dilation factor. I can see that the pi's are going to cancel, which tells me that my period is 2 radians, and that is exactly what our graph tells us as well. So now that we've kind of looked at our new adjustments for this equation, I can see the amplitude is 6, and I'm looking for where this equals a positive 1. And so all the answers between 0 and 6, that's going to show me that I have 1, 2, 3 answers there where the function is increasing, and 1, 2, 3 answers there where the function's decreasing. So I'm looking for 6 answers. So going back to the equation, the first thing that I'm going to do is get the cosine function alone by dividing both sides by 6. And so I will have the cosine of pi x equals a sixth. Now that the cosine function is alone, I'm going to draw a picture to show us where cosine will equal a positive 1/6 ratio, which will be in the first and in the fourth quadrant. I'm going to take the cosine inverse of 1 over 6, making sure that we're in radian mode, and we end up getting 1.4 radians roughly. Remember, the nice thing about cosine is that once you know one angle, you know the negative of that angle would also be a solution, so negative 1.4 radians. Now, what makes this problem different is 1.4 radians, if I plugged it into regular cosine, would give me 1/6. But I'm taking whatever angle I'm plugging in and multiplying by pi before I put it into cosine. So to work backwards, I know that the inside needs to equal roughly 1.4 or roughly negative 1.4. And so to find our x values, we need to divide those two answers that we found by pi. And then once we do that, we will end up getting x is approximately equal to 0.4467, and again, you would do that in your calculator. The other answer would be then negative 0.4467. So these are my general solutions, or my starting points, we could say. This is not going to give me an answer because it's not in between 0 and 6, but I do know that this is going to be an answer. Normally with cosine in radians, we would add increments of 2 pi to find more answers, but if you look back to our graph, our period is not 2 pi, it's 2 radians. So each of these answers are going to be 2 radians apart, not 2 pi. And so I'm going to add 2 radians to get another answer. And so, again, we could do this in our calculator, dividing this answer by pi. That's how we got this 0.4467. Add 2 to it, and I'm going to get 2.4467. And then I'm going to add 2 to it one more time, and that does keep me under 6. So I do need one more answer, so add 2, and I get 4.44, and we could round that to 6, 7. So there's 3 answers. Let's look back at our graph. And so we just found this answer, and this answer here. I solved the other 3 to find, and keep in mind that we got a negative answer. So I'm going to have to add 2 once, twice, 3 times to get these other solutions. So I'll start by adding 2, and again we could use our calculator, grab the negative of that angle, add 2, there's my first answer, second, and third answer. So writing out this work, we then get 1.5533, add 2 radians again, we get 3.5533, add 2 radians again, and then my last answer, 5.5533. So here's 1, 2, 3 answers, and then here are the other 3. So we found all 6, and we're done.